Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at wildcard masking. We'll be discussing wildcard mask overview, wildcard mask types, wildcard mask calculation, and finally, we'll look at wildcard mask keywords. This episode is part of my series on network security. I'm Kevin here at KevTechify. Let's get this adventure started. A wildcard mask is like a subnet mask because it uses the ANDing process to identify which bits of an IP version 4 address to match. However, they differ. The wildcard mask and the subnet mask, they differ in the way they match binary ones and zeros. Now, unlike the subnet mask here, and once again, the subnet mask here, a binary 1 is a match, a binary 0 is not a match. In a wildcard mask, it's the reverse. And what that means here is, so in a wildcard mask, if it's a 0, let's match it. If it's a 1, ignore it. 0's a match, 1's ignore in our wildcard mask. Okay, let's go through a couple examples here. So we have the wildcard mask here of all zeros. The last octet here in binary is all zeros. And once again, remember, 0 means match. And so what we're going to do is we're going to match all the octets. We're going to match all 32 bits here of that IP version 4 address. Here we have another wildcard mask. We have three zeros and then a 63 at the end. Convert that 63, the last 8 bits look like 00 followed by 6 ones. And what we're going to do is we're going to match the first 3 octets because once again, the first 3 octets here are all zeros and a 0 means a match for a wildcard. Then we're going to match the 2 leftmost bits of the last octet. So these 2 right here, we're going to match them because those are our zeros. And then the last 6 here, we're going to ignore them. We don't care what the value is. We're not going to match those. So these last 6 here, they're ones, we're ignoring them. Here's another example. We have the first 3 octets are 0. So that means we're going to match them. So we're matching the first 3 octets. In the last octet, we have a 15. Changing that into the binary there gives us 4 zeros and 4 ones. So having zeros here, we're going to match the 4 leftmost bits and we're going to ignore the last 4. And see, up to now, we have all zeros, right? We have all zeros, 3 octets here of zeros, 4 bits of zeros. So we have all zeros to the left and all ones to the right. Here comes another slight difference than the subnet mask. In a wildcard mask, you can switch back and forth to zeros and ones and zeros. Here's an example. In this example, we have three zeros in the first octet, so we're matching the first 3 octets. Then we have 252, take 252, turn that into binary, and we have 6 ones. 6 ones here, once again, remember, 6 ones is ignoring that. So we're going to ignore these first 6 bits, but then the last 2 bits, we're going to match those because we have zeros in those bits. And once again, a 0 in a wildcard mask means we are matching that. So we have zeros, first 3 octets are zeros. Then we have ones, we're going to ignore those. And then we have the last 2 bits. So we go from zeros to ones to zeros. Where in a subnet mask, once we changed, we could never go back. And here's another example. We have 3 zeros here and then 255. 255, we convert that as all ones. So what we're doing is we're having zeros in the first 3 octets, so we're matching those 3 octets. And then the last octet is all ones. Once again, a 1 here is we're ignoring it, so we're going to ignore that whole last octet. Okay, so in the wildcard mask, Zeros mean match, 1 means ignore when we look at that. Here we can see a wildcard mask to match a host. We want to match that host IP version 4 address, so we want to match all 32 of those bits. Here we're having the IP version 4 address 192.168.1.0, and we're going to put in, because we want to match all 32 bits, we're going to put in all zeros, because once again, remember, in a wildcard mask, zeros are matching. And so we change it to the binary. So we got 192.168.1.1. Now in binary, we want to match all of them. And so the only permitted address is we're going to AND them together. A 1 and a 0. So you AND a 1 and a 0 together. That will give you a 1. A 1 and a 0 gives you a 1. A 0 and a 0, that gives you 0. So we work through there. Basically, it's just a repeat of what we came up with for the binary for the IP version 4 address. Right here, this is the permitted IP address through our wildcard mask when we do our matching. Here's a wildcard mask to match an entire IP version 4 subnet. We want to match an entire subnet on a Class C address. So we start off here with the IP version 4 address of 192.168.1.1. We turn that into binary. And then we use our wildcard mask. Once again, zeros, that means matches. So 0 is matching. And we want to, so we match the first 3 octets, and we don't care about the last octet, because we're looking at matching that whole IPv4 address. And because we don't care about the last octet, we're going to put all ones into that. So we write the binary out here. And now we go through our ANDing process. So 1 and 0, right here, 1 and 0, that gives us 1. 1 and 0 gives us another 1. 0 and 0, that gives us 1. So we continue all the way through until we get down to the ones here. When we get down to the ones here, a 0 and a 1, that gives us a 0 again. So 0 and 1, 0 and 1, 0 and 1. And 1 and 1, that gives us a 0. That gives us all zeros here in the last octet, while the first 3 octets, they match what was there. And so the first 3 octets that we had is 192.168.1. So that matches there. So our permitted address is here, 192.168.1. The last octet, when we ANDed it, we got zeros, so that turned out to be a 0 here. And because that's where the difference is in our network and host portion, we can turn that into a /24. So the permitted addresses are 192.168.1.0/24. Now we're going to look at a wildcard mask to match an IPv4 address range. What we're looking at is we have the IPv4 address here, 192.168.16.0, and then this is our wildcard mask. We have 0.0.15.255. So the first 2 octets here are zeros. Then we have .15 in the third, so when we change that to zeros and 1 in binary, we get 4 zeros and then 4 ones. Once again, meaning where there's a 0, we're matching. So all the way up to here, this is a match. After here, we have our 4 ones, and then the last octet is all ones. We are not matching these when we're doing our filtering. So we're not matching the last 4 plus 8, 12 bits. So we matched the first, what is that, 20 bits, and not match the last 12 bits. We can go down here, and now we see our ANDing. And what we have to do here is we have to figure out, well, what is this range here? What are we doing? When we AND these together, we can see that we get up to here is identical. Right? So we match all of these, that all stays the same through here. But then we start ANDing here. So we got 0 and 1. And now to calculate the range here, we have to look at what is that wildcard mask giving to us and what is the normal wildcard mask. The normal wildcard mask here for a Class C address, a 192 address, is right here. So this is the normal. This here is what was given to us. This is that custom wildcard mask that was given to us right here in that .15. And now to get our range, we have to find the minimum value here. So what we do is we put all four zeros in here, and then we find the maximum range. To find the maximum range, you put the maximum value. That's all ones in binary. And that gives us, when we start looking at it, we have a 1 in the 16 followed by zeros. That gives us our third octet. And here we have 5 ones here leading off. So this was 15 plus 16. That gives us 31 in our octet. So this is the range of addresses that will be permitted using this network address and this wildcard mask. If you like this episode on wildcard masking and you get value out of it, and depending upon the platform you're using, please click that like button, give a 5-star rating, leave a comment. Doing this supports the channel, which in turn helps me bring you more great content. Click that notification bell to turn on notifications to be alerted every time I release a new episode, and there are a bunch more episodes headed your way. You can also visit my website at KevTechify.com for all my details on how to get this episode in video and podcast form. Calculating wildcard masks, sometimes it can be a challenge. As you saw in the previous slides, looking at that binary, it can be challenging. Now, there is a shortcut method here that allows us to calculate that wildcard mask pretty easily. What this is this method is used to subtract the subnet mask from 255. So what we do is we start out with the maximum value here of 255, 255, 255, 255, basically all ones there, and then we put what our subnet mask is. A lot of times, either the subnet mask is given to you, or it's a lot easier to calculate than the wildcard mask because we're used to calculating that. So we go ahead and write that down here in decimal form. So 255, 255, 255.0, and then we subtract these two together. So we subtract this from there. So starting here, 255 minus 0, that gives us 255. Then 255 minus 255, 0, 0, 0. And so our wildcard mask was a little bit easier to figure out once we started with the starting value of all ones, or 255s, put our subnet mask in, and we were able to subtract that. Keywords here, we can use keywords to reduce ACL keystrokes and to make it a little bit easier to read your access control entry. When we look at these access control entries, and once again, an access control entry is one line in your access control list. So an access control list consists of multiple access control entries. As we look at it here, we can see that it's the access list, then we give the number of it, and then it's either permit or deny. And then here, this is either the IP address, or network address. So it's one or the other. Go ahead and specify that, and then this is followed by the wildcard mask. We have the wildcard mask. As we talk about these wildcard masks, remember 0 is a match and 1 is ignore. Here for this first one, what we want here is this host at this IP address. So this IP address here, and we want to compare all of these bits, all 32. So we want a single host address matching all 32 bits. So we're going to have 32 zeros here, convert that into decimal. That gives us 0.0.0.0 for our wildcard mask. Once again, 0 is a match. And so we're going to match all 32 bits. So we're going to be a host. You can go and write this a different way. So down here, we have access list 10, permit, and then we have the keyword host. What this keyword host is equal to is all zeros at this point. So what we're saying here is we want to match all the bits of whatever address follows here, and then this is the address of our host. And so some people consider this a little bit cleaner and easier to read. We are dealing with just one host at this IP address. Another one is where we're looking at, so here we're creating a second access list 11, and we're going to permit, here's our IP address of, or network address of 0.0.0.0. Okay, that seems a little weird for an IP address or a network address, but then let's look at the wildcard mask. Our wildcard mask here is 255, 255, 255, 255. Remember that these are all ones, so 255 is equal to 8 ones, so we have 24 ones here. 1 is equal to that ignore. So we're going to ignore all 32 bits. Basically, we're saying we don't care what the address is, we're going to match it to this statement. And so what we have here is, that's why we put the 0.0.0 in there, because we know we don't care where it's coming from or where it's going. We just want to send all that traffic here. And at this point, when you have 0.0.0.0 as your network address, and you have your wildcard mask is 255, 255, 255, you can actually go and use the word any. So right here, you have the word any. You can substitute all of that for this right there. It was my pleasure to provide you with this wonderful episode on wildcard masking. If you like this episode and you got value out of it, and depending upon the platform you're using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel and click that notification bell. All my socials and contact information are on my website, KevTechify.com. You can get all of these episodes in video and podcast form. In the upper right is my playlist for my series on network security. In the bottom right is one of my favorite episodes that I linked just for you. Thank you so much for watching this episode of my series on network security. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.